Hello and welcome to our series on Trendlines. This is part one. We're working with a very specific application, a very specific example for Trendlines, and this is also in a very specific context. So, look, we've got this data which is electricity bill for a house, a residential building, and these are electricity bills in Pak rupees. This is a house situated in the eastern part of the city of Lahore, Pakistan. We've got 90,000 rupees as the electricity bill for September 2024, 70,000 for October 2024, and so on. So we've got 12 months of electricity bills before solar panels were installed on the rooftop. And then we've got 2 months of data after solar panel installation. That's September 2025 and October 2025, right? So the context for this is quite simple. We want to understand if there is a pattern or if there's a trend within the pre-solar installation data, and if that trend or pattern could be extended to post-solar installation data. And if we could do that, then is there a possibility where we could predict the electricity bill for the remaining 10 months in the 12-month cycle that we are looking at, right? And if we could predict those bills for the remaining 10 months, what savings do they represent, right? So what are the projected savings? So that's our goal. That's something we're working with. Obviously, there are a bunch of assumptions. For example, the unit price of electricity, the cost of electricity for 1 kilowatt hour, 1 unit, is the same for 2024 and 2025. We're assuming that. We're assuming the electricity consumption patterns are also the same between 2024 and 2025 by the residents of the house. We're assuming there are same number of occupants, same number of people living in the house. So there are some assumptions that we are working with. But let's get right into it. So this is our raw data. By the way, when you look at the raw data, it's always a good idea to have a look at what the data tells you right away. So we know we have these 2 months for September and October, and we could compare straight away 2024 and 2025. You see a reduction in the electricity bill. You see a reduction in electricity bill from 90,000 to 63,000, 70,000 to 30,000. So you see a reduced electricity bill after the solar panels were installed, which makes sense, right? Uh, I've also been told that the solar panels, the configuration that we have in this solar system was uh, we do not have battery backup for this, and we are also not sending electricity back into the grid. So there's no net metering, so to speak. There's no credits on the units, and the whole idea is that during the daytime, whatever the solar panels produce is basically uh, consumed by the household, and they sort of facilitate in your bill, right? Which is why there is reduced dependency on the grid, and that is the reason why you have a reduced electricity bill, because that need in the house is being met by the solar panels. All right, let's see if we can identify a trend in this data set. So we've got this data set. What I'm going to go ahead and do is create a scatter plot. Again, so after selecting them, go to insert, choose a scatter plot from right here. Okay, so I've got this scatter plot right in front of me, and I can see there's a variation in the data, and we can obviously put up a trend line on top of it in just a moment, but you could see a trend in the data right away. But one of the things that bothers me is the x-axis. Notice how there's July right here. There's no August. Yes, we don't have data for July and August, but it still shows up here on the axis. Then there's September written here, but the data point is kind of here. Remember, this is our first data point, so it kind of seems like messed up. One of the reasons why this happens, or one of the ways you could avoid this, is by, instead of working with the scatter plot, it's a good idea to work with, and I'm going to select this one more time, go to insert, and work with a 2D line plot to kind of just show you what I mean. Look, this is a 2D line plot, and notice how the axes are nicely formatted by default rather than a scatter plot, right? So September, and then you have these protrusions on the axis that kind of mark where September ends. So this is a data point for September, then a data point for October, and then November, December, and so on. So it's a good idea to work with a 2D line plot rather than a scatter plot. So let's get rid of the scatter plot and work with our 2D line plot. And this is the actual data. And let's see if we can bring a trend line on top of this, right? So I've selected my chart. I'm in the design tab, add chart element, trend line, and I'm going to bring more trend line options. I'm going to choose one of the trend lines. I have a lot of options, but I'll post a link in the comments in the description of this video for a detailed analysis on what polynomial order to choose. But long story short, we don't want to choose a lower order because that oversimplifies the trend, and we don't want to choose a higher order because that overfits to the data, and the trend line seems to hug super close with the original data points, which is not a good way to identify a trend. So you want to choose something in the middle which captures the trend but is not an oversimplification. Probably go with order 3 or 4. Order 3 makes more sense to me. Kind of the electricity bills kind of flatten out, they go down, and then they rise up, which also, by the way, coincides with the seasonal variation that we have for Lahore. In December, January, November, in these months, the electricity bill is reduced. There's no cooling load. These are winter months in Lahore, and then May, June, July are kind of summer months, and you should see inflated bills because of the cooling load, right? So that's our trend line. There's our original data in solid blue line. We've got our months set up on here. And one of the reasons why I've not set up my September and October post solar months right under here is because then those months would appear on my graph on the right hand side. After August 25, there's going to be September 25 and then October 25. And I don't want them to show up on the right hand side because then those data points will be here. And it will become difficult to compare a data point here, for example, September 2025 data with a data point of September 2024 on the left hand side. So you don't want to compare a data point on the right end of the chart with a data point on the left end of the chart. So it becomes difficult to compare two Septembers. So what we're going to do is we're going to overlay the 2025 months on top of the 2024 months so that Septembers are in one place, Octobers are in one place, Novembers are in one place. But we can't call it 2024 because it's also 2025 then. So we're going to get rid of these 20 years from the axis, just keep them generic months. So we have a plot and a trend line for in blue for 2024 data, this data, pre-solar data, and then we bring in the post-solar data on top of this. We'll do this in part 2. Remember to check out part 2. I'm going to put up a link for that. Thank you so much. I'll see you in the next one.